Okay, here we go, guys. Part 3, the final part of our big EOC review packet. So here we go. Let's finish it off. Number 43. The table shows a few values of each function for different values of x. Which would you predict best describes the comparison of the function values for f of x and g of x? So here are x values. Remember, f of x are your y's. So basically we have y's and we have z's, really. In this case, we have two different functions here. We've got to figure out which one of these is true. It says the values of f of x will always exceed the values of g of x. All of these guys will always be greater than these values. Well, on the surface, it looks like that's true. 0 is greater than negative 10, 4 is greater than negative 6, 8 is greater than 6. But if you follow the pattern here, these guys, the f of x's, are just doing what? They're just going up by 2. What are the g of x's doing? How do I get from negative 10 to 9? I'm adding 1. How do I get from negative 9 to negative 6? I add 3. From negative 6 to negative 1, add 5. I see a pattern here, plus 7. So if I continue the pattern, plus 9, this value is going to be 15. If I continue this pattern, that's only going to be 10. This would be 0, 1, 2, 3, 4, 5, of course. Okay, so now, are the f of x values always greater than the g of x? No, they're not. This guy is not greater than 15. Okay, so that's not true. The values of g of x will always exceed the values in f of x. Obviously not. That's not true. Negative 10 is not greater than 0. The values of f of x exceeds the values g of x over the entire interval from 0 to 5. These guys are always bigger than these guys going from 0 to 5. That's not the case, because if we followed it all the way to 5, then we can see that the f of x in this last interval here is not greater than g of x. Okay, so that's not true. So obviously D is correct. But let's just make sure. G of x exceeds the values of f of x over the entire interval from 5 to 6. So if I continue the pattern, I'm adding 2 here, then I'll add 11. That's going to be 26. Okay, so from 5 to 6, from this interval, are the values from g of x greater than the values of f of x? Yeah, 15 is greater than 10, 26 is greater than 12. So yes, that one is correct. Okay, so you might see this on the EOC, guys, talking about these intervals. I'm just looking, if it says interval from 3 to 4, I'm only looking here. If it says from the interval from 0 to 1, I'm only looking here. Okay, so keep that in mind. All right, what is the center of the circle given by the equation x squared plus y squared minus 10x minus 11 equals 0? So we're not in standard form. Okay, remember, standard form is this: x minus h squared plus y minus k squared equals r squared. Okay, that will be on your formula sheet. So I've got to complete the square here. So I'm going to match up my x's. Let's see if I can give myself plenty of room here. I might have to write a little small. X squared minus 10x, and then here's a blank, plus blank. And then I match up my y's. I don't have any y's. All I have is a y squared. So I got plus y squared. Now where does this constant go? The constant always goes to the other side. I'm going to move that to the other side. So those cancel. So that's going to be equal to 11. Okay. And now we're going to complete the square. I hope we're good at this by now. Complete the square is half of b squared. Half of negative 10 is negative 5. Negative 5 squared is 25. So I'm going to stick a 25. I'll do this in green. I'm going to stick a 25. Maybe y'all can't see this. Maybe I should zoom in a little bit. Yeah, that's a little bit better. Sorry about that. All right, so 25 goes in this blank. So remember, when we complete the square with circles, we're going to have, normally we have 2 plus blanks, right? Plus blank and 2 blank. But notice we don't have a second blank because the y's only had a y squared value. We didn't need to complete the square on the y's. So that means, of course, I need to put a 25 in the other blank. Okay, so now, I'll do this in different color. The whole purpose of completing the square is so I force these guys to become a perfect square trinomial that I can factor. How does that trinomial factor? It factors as half of b, half of negative 10. So that's going to factor as x minus 5 squared. Or the other way to think about it, what are the factors of 25 that add to negative 10? That's negative 5 and negative 5. So there's your x minus 5 squared. And then I just have a plus y squared. And then I just combine those. That's just going to be plus equals 36. So the question is, what is the center? Okay, so the center is I flip the signs. That's going to be positive 5. I don't have anything there, so guess what that is? 0. Okay, so the correct answer is A. Now, what if they had asked you, what is the radius? Okay, remember, that's r squared. That's an r squared, so I got to take the square root of that, so the radius would be 6, just in case they ask that. Okay, 45. A circle is centered at the origin and has a radius of 3 units. A horizontal line passes through point 03. In how many places does the line intersect the circle? Whoa. We've never seen that kind of problem. Read it again. A circle is centered at the origin and has a radius of 3. Do you see any graph paper here? You see a graph here? No. So what are you going to do on the EOC? You're going to get out your scratch sheet of paper. They're going to give you a piece of graph paper. Okay, so use that graph paper. I would come over here to the side. I don't have graph paper, so I'm going to come over here and just kind of do this. I'll do it right here. So I'll make myself a little coordinate grid. It's centered at the origin. Okay, so the circle centered at 0, 0. So and it's got a radius of 3. So let's come out here and go 1, 2, 3. -1, -2, -3. 1, 2, 3. -1, -2, -3. Okay, so there's my circle. Guys, this doesn't have to be perfect. Just draw yourself a halfway decent circle. Okay, all right, so there's my circle. And then it says a horizontal line passes through the point 0, 3. So if I have a horizontal line that comes through right at 0, 3, okay, how many places does it intersect the line? This is going to be a tangent line, guys. It's barely touching the circle at that one infinitesimal spot is 0, 3. That's a tangent line. So it's only going to intersect the circle in one spot. It's barely going to touch it. Okay. If it said that a horizontal line goes through point 0, 2, then I would have a horizontal line that looks like that. That would intersect the circle at 2 spots. Okay, but we're barely touching the circle. All right, which statement best describes the graph of f x plus 6? Okay, this is our transformation stuff. All right, so what are they talking about? Well, look at your answers. Shift up 6. Now, oh, okay, now I see what they're talking about. All right, they want to know what is the transformation here. This is a translation, shifting, moving up, down, left, right, 6. Okay, remember, if we go back to y equals a times x minus h squared plus k, remember your a value, if there's a negative out front, the negative tells you that's a reflection. That tells you the parabola opens down. Okay, that's the negative. The a value tells you whether it's a shrink or compression. Is this a skinny parabola or is this a really wide parabola? The h value tells you your horizontal shift. That's your left or right. But you got to remember, guys, this is tricky. Remember, there's a minus sign there, so it's opposite of what you think it would be. Your k value is your vertical shift up and down. Well, what do we have here? This is x plus 6 in the parentheses. So this is like y equals maybe 2 parentheses x plus 6 and then maybe minus 3, something like that. Okay, squared, something like that. So this is my horizontal shift, left and right. But since it's plus 6, remember that's backwards. You would think it would be going 6 in the positive x direction, but it's minus h, so it's backwards. So we're going that way. So we're actually going left 6 units. Okay. If this was a -3, what would that be? That would be a shift down 3 units, right? If that's a 2, what would that be? That would be a stretch of 2. Okay, we're stretching the rubber band. Okay, number 47, which is information? What? Oh, that's a typo. Which information is needed to show that a parallelogram is a rectangle? Okay, so I wish I had a copy of my printout. So all this quadrilateral stuff, you know, diagonals of a rhombus bisect the angles, they're perpendicular, the mid-segment of the trapezoid is the average of the sum of the bases. All that stuff, guys, is on the graphic organizer that I passed out to you guys when we were in Chapter 5. So if you go to my website, markmanise.com, if you go up to Resources, Student Guided Notes, and you click on the very first one, I believe, Chapter 5, you will have access to that full graphic organizer that I passed out to you guys earlier in this semester that has everything summarized for you for all the different quadrilaterals. Okay, so I would suggest that you study that. That's also in the 182-page document, by the way, that we discussed in class. All right, so which of these shows that a parallelogram is a rectangle. Diagonals bisect each other. Does that mean it's a rectangle? No, absolutely not, because the diagonals of a parallelogram bisect each other. Okay, that was one of our traits. Okay, that's just true of all parallelograms, so that doesn't mean it's a rectangle. The diagonals are congruent. Are the diagonals congruent in a rectangle? Yes, they are. Okay, so this is our answer. However, let's look at the other ones. The diagonals are congruent and perpendicular. Okay, that is only true in a square. The diagonals are the same length, and the diagonals form 90-degree angles in the middle. So that's not it. That's a square. The diagonals bisect each other and are perpendicular. Okay, if the diagonals bisect each other and they're perpendicular, that's true of a rhombus. Okay, the only difference between a rhombus and a parallelogram is that all four sides are the same in a rhombus and the diagonals are perpendicular. So these are the traits and characteristics of a rhombus. Okay, so the only one that's true of just a rectangle is that the diagonals are congruent. Okay. Oh my goodness. Oh my goodness, we only got 2 pages left. We're getting close, guys. We're getting close. 48. If all the medians of a triangle were constructed, what would be the point? What would the point where all they intersect be called? Okay, guess what? We have this. All of my children are bringing in, finish it, peanut butter cookies. Okay, what does the A and the O stand for? That's your altitudes. Your altitudes intersect at the O. Remember the O? Oh, that's a long word. Orthocenter. Sorry, I can't squeeze that in there. My children. Medians intersect at the C. Is that centroid or is that circumcenter? Remember, we have 2 C's in here, okay? This one is centroid, and I'll refresh your memory on how to remember the difference between those two in just a minute. Are bringing in. AB, angle bisectors intersect at the I in center. Okay, peanut butter, perpendicular bisectors intersect at the circumcenter. Sorry, I can't fit all that in there. Okay, so altitudes intersect at the orthocenter, medians intersect at the centroid, angle bisectors in center, peanut butter perpendicular bisectors intersect at the circumcenter. How can you tell the difference between centroid and circumcenter? Which one is longer? Which word is longer? Children? Which one is longer? My children or peanut butter cookies? Okay, peanut butter cookies is longer. So which word is longer, circumcenter or centroid? Circumcenter is longer. Okay, so peanut butter cookies, circumcenter. So let's answer the question. All the medians were constructed. All the medians intersect at the centroid. Okay, 49. Which students would be members of the group A, upside down U, B, tick? Okay. Let's don't worry about the tick for a second. Always do the parentheses first. What does the upside down U mean? That means the overlap, the intersection. Okay, so what's the intersection of group A and group B? The overlap is just Bill. Okay, however, it's tick. We want the tick means opposite, so I want the opposite of Bill. Okay, so that means give me everybody but Bill. So that's going to be Amber, Chris, and Dave. Okay, remember, just refresh your memory. U means union. So A union B means give it all to me. Give me everything in circle A, give me everything in circle B, give me the overlap, give it all to me. A upside down U, B means the overlap. Okay, literally the overlap on the Venn diagram of the circles. And then A tick means opposite. A prime means not A. Give me everybody other than A. Okay. 50, in a particular state, the first character on the license plate is always a letter. The last letter is always a digit from 0 to 9. Let V represent the set of all license plates beginning with a vowel. Okay, so V begins with a vowel. O represents the set of all license plates that end with an odd number. O for odd, I guess. Which might be a license plate that belongs in the V upside down U O. Okay, what did we just say up here? The upside down U means the overlap at the same time. Okay, so in other words, this is asking which license plate satisfies both the V and the O at the same time. Okay, and V means begin with a vowel, so it's got to begin with a vowel, E and A. Okay, so I can scratch out B and I can scratch out D because they begin with a consonant. Okay, and then it's also got to satisfy O. O represents the license plates that end with an odd number. Well, I can scratch out A because that ends with an even number, so the answer has to be C. This is V and O, the overlap at the same time. It begins with a vowel and it ends with an odd number. 51, a random survey was conducted about gender and hair color. This table records the data. What is the probability that a randomly selected person has blonde hair given that the person selected is male? Looky look, guys. Look at that. Given. Okay, the word given. All right, so what is the probability that a person selected has blonde hair given that they are male? Okay, so if I wrote this with our notation, that would be probability of blonde given that they are male. Okay, so where does the given go? Okay, so in these two-way frequency table, the given, remember the way I taught you, given tells you whether you're looking at a column or a row. Given that it's male, okay, male comes second. Where is the word male physically located? It is located in this row. Okay, so we're only looking at numbers in that row. I don't need these numbers. I'm only looking at the numbers in the row. Okay, so the total always goes. Oh, they didn't give us the total. Huh. Okay, so sorry. Sorry, I guess I actually do need. I'm used to seeing these totals in the charts here, and we don't have the totals. But anyway, so we're only looking at the males. Okay, so how many total males do I have? We're going to actually have to come out here and do the total ourselves. Okay, so we're going to add these together. Let's add these numbers. 548 plus 876 plus 82. That gives me a total of. Actually, I guess I should. I'm sorry, guys. I didn't realize the total wasn't in this chart here. So the total is 1506. So I'm only looking at the numbers in this row. Okay, I had to extend my row here a little bit. Okay, so the total always goes on the bottom. Okay, so out of a total of 1,506 males, what is the probability that they're blonde? All right, how many blondes do I have? I have 876 out of a total of 1506. Okay, so if I type that into my calculator, 876 divided by 1506, that gives me 0.58, which is this number here. So out of all the males, 58% are blonde. Okay, that's basically what that's asking. Okay, let's keep going. 52. Assume that the following events are independent. The probability that a high school senior will go to college is 72%. The probability that a high school senior will go to college and live on campus is 46%. What is the probability that a high school senior will go to college? What's that word? And live on campus. Remember, guys, the formula sheet, they're nice to you. They actually tell you what to do. When you see the word and, you multiply. When you see the word or, you add and possibly subtract out the overlap. Okay, so I'm going to multiply the probability that they will go to college and live on campus. I'm just going to multiply these two numbers. 72% chance of going to college, 46% chance they live on campus. You multiply those two numbers. Voila, 0.3312. That's a 33% chance. Okay, let's keep going. Oh my goodness gracious. This is a hard one. This is a tough one. This is about as tough as it gets for probability. I hope they don't give something this hard to you on the test. Miss Scott surveyed 240 men, 285 women about their vehicles. Of those surveyed, 155 men and 70 women said they own a red vehicle. If a person is chosen at random from those surveyed, what is the probability of choosing a woman or a person that does not own a red vehicle. That's why this is hard, because we throw that not in there. Okay, so remember, when you see the word or, we're going to add. So let's break this down. What are the chances? What's the probability of choosing a woman? How many women do I have? I have 285 women. So that's going to be 285 out of a total. How do I get, what total are we talking about? Out of the total of men and women. Well, I need that number. So I'm going to have to add 285 women plus 285 women plus 240 males. I've got 525 people. So if I were you, I'd just write this down somewhere. Scratch sheet of paper. We got 525 people we're talking about, men and women. Okay, so 285 women out of a total of 525. Okay, that's the probability of choosing a woman. Or means add. Now I want the probability of not owning a red vehicle. Okay, well, 155 men and 70 women said they do own a red vehicle. Okay, so if I add 155 plus 70, I've got 225 people that own a red vehicle. Okay, but that's not what I want. I want those who do not own a red vehicle. So what do? I'm going to subtract this number from the total. 525 minus 225, that's going to be 300 people don't own a red vehicle out of the total of 525. Alright, still not done yet. Remember, you got to subtract out the overlap. Every time you add, you got to see, can I be this and this at the same time? Can I be a woman and somebody that doesn't own a red vehicle at the same time? And the answer is yes. So we have to subtract that out so we don't double count those people. Okay, so we got to figure out how many women do not own a red vehicle. Okay, well, we've got 70 women who do. So the rest of the women don't, and that's what we want. So I'm going to have to use this number. Out of the 285 women, 70 do own a red vehicle. So if I subtract 70 from the 285 women, that will give me the number of women who do not own a red vehicle. 285 minus 70 is 215. So I have to subtract out this overlap. I got to subtract out these 215 people out of 525. 215 people are a woman and don't own a red vehicle at the same time. Okay, so if you add those numbers together, keeping the denominator the same, I'm going to add 285 plus 300 minus the 215. That gives me 370 out of the total of 525. Well, notice that's not any of the answers. So we need to let our calculator do the work. 370 divided by 525 people gives me a decimal. I'm going to go math, fraction, enter, 1, 2, and that's going to convert that to a simplified fraction for me, 74 over 105. Guys, that was tough, okay? Not going to lie. So rewind the video, listen to that again if you were having trouble keeping up with that, all right? 54, each letter of the alphabet is written on a card using a red ink pen and placed in a container. It says each letter of the alphabet is also written on a card using a black pen and placed in the same container. All right, a single card is drawn at random from the container. What is the probability that the card has a letter written in red ink, the letter B, or the letter R? This is the first time we've ever seen this kind of problem. We've got an or. Well, we got three things we got to add together. I need it to be either a letter written in red ink, or the letter B, or the letter R. Okay, that's kind of a long problem. What are you going to do in a long word problem, guys? Read it again. Read it again. Each letter of the alphabet is written on a card using a red ink pen and placed in a container. Each letter of the alphabet is also written on a card using black pen and placed in the container. So I've got a container of a bunch of red ink letters and a bunch of black ink letters. A single card is drawn at random from the container. What is the probability the card has the letter written in ink? Okay, so let's figure that out first. All right, so the chances of, so this is where I can go and write this out. We're going to do probability of A plus the probability of B, and then we got to subtract out the overlap if they can be A and B at the same time. Okay, so we got to figure out what are the chances that we draw a letter written in red ink. Okay, well, how many letters are in the alphabet? That is not a trick question. There are 26 letters in the alphabet, right? But I've got 26 red ink letters and I've got 26 black ink letters. All right, so of course half of those are going to be red. So the chance of pulling a letter that's got red ink on it is 26 out of 52. This is kind of like a deck of cards, right? I got 26 black cards, 26 red cards, 26 letters, 26 red letters, 26 black letters. All right, so that's the red ink. And then what are the chances of drawing the letter B? Okay. How many B's do we have in there? Let's see, I'm going to make sure I'm reading this correctly. Okay, so it's asking the letter B or the letter R. Okay, so we can actually split this out in two different ones if you want to, guys. I could do it this way. I could do, I only have two B's, right? I've got a red B and a black B. So I could do, there's 2 out of 52 B's plus 2 out of 52 R's. Okay, I could do it that way. Or I could just combine these together. So another way to do it is say, okay, I've got 26 red letters. And then how many B's or R's do I have in the container? I've got 4 of those, 2 B's and 2 R's. So if you wanted to, you could combine these. Either way, whatever you prefer. I was just checking my old answer key, and I'd already actually combined them in my old answer key, which is fine. But then I got to see, can I subtract out any overlap? Can I be the letter B or the letter R and be a red card at the same time? And the answer is yes. I have one red B, and I have one red R. Okay, so how many do I have to subtract out? I got to subtract out 2 of those. Okay, because if I don't do that, I'm counting the red B, I'm counting that in the red ink, and I'm also counting that in the B or the R, so I got to subtract those out. So that's going to be 26 plus 4, which is 30, minus 2. That's going to be 28 out of 52, and that is going to reduce to 7 out of 13, which is going to be this one. Okay, so let me just recap that. The 26 out of 52 is the red ink. The 4 after the 52 is the B or the R. And then the 2 out of 52 is the red B or R. Okay. All right, so yeah, those are some tricky probability questions. Those aren't quite as easy as some of the ones we've worked on in class. So I'm hoping that they won't try to trip you up too bad on those probability problems. 55. Which of the answers below would be correct form of the converse and the biconditional of the following statement? If you study hard, then you will make good grades. Okay. All right. So the converse, remember the converse is, remember, to switch the shoes. Okay. So if you study hard, then you will make good grades. I flip that. If you make good grades, then you study hard. That's the converse. But they want the biconditional. So if you guys remember, a regular conditional statement has if and a then. Okay, if you study hard, then you make good grades. A biconditional has if and what? Only if. Okay, so the only two that have if and only if are A and B. But remember, I got to switch it. So it should be you make good grades if and only if you study hard. So that should be B. A is wrong because they didn't switch it. They put in the if and only if, but they didn't switch these two. Okay. All right, 56. What would be the final coordinates for a triangle located at those 4 points if the triangle is reflected around the x-axis and then rotated 90 degrees about the origin? Okay, well, goodness gracious. Do you have any graph paper here? No, you don't. Okay, so I would suggest that you use your graph paper. I'm going to come over here. I'm going to draw myself a little graph, but you guys will have graph paper. You can just go straight to the paper and plot it. So I'm going to have to, for the purposes of this video, I'm going to have to actually make some little marks here. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Why am I using 6? Because 6 is the highest number for these points. 6, 6. Ooh, I gotta be careful what I'm saying here. 6, 6. Ooh. Okay, 6, 6, negative 6, negative 6. All right, so it's reflected, these points, so let's go ahead and plot those. Negative 3, 4. So 1, 2, 3 up. 1, 2, 3, 4. There is negative 3, comma 4. 6, 2. Here's 6 up 1, 2. There's 6, comma 2. And then C is 1, negative 2. Here's point C. Here's point B. 1, negative 2. And there's point C. No, check that. That's point A. Sorry. ABC. All right. So we are reflecting around the x-axis. Okay. So one way to do it, if you want to remember the rules, guys, you can. So when you're reflecting, you got to remember whatever axis you're reflecting around, you change the sign of the other guy. So if you reflect around the x, change the sign of the y. If you reflect around y, change the sign of the x. Or the way I kind of taught you guys to do it is just count with your fingers. We're up here at 4. So 1, 2, 3, 4. Remember, I'm flipping around the x-axis. There's my x-axis. So if I'm 4 away here, I got to be what? 1, 2, 3. I got to be 4 away over here. That's going to be negative 3, negative 4. Once again, you flip the sign. You flip the sign of the other guy. Negative 3, negative 4. This guy, B, is 2 away on the top, so it's got to be 1, 2. It's got to be 2 away on the bottom. This would be like A prime. This would be B prime. So I'm going to flip the sign of the y, or I'm 2 away on the low side, so this is going to be positive 6, negative 2. And then this guy, C, this guy is below the x-axis. When I reflect this guy, it's going to be above. I'm 2 away below, so I'm going to be 2 away on the top side. So this is going to be 1, comma, positive 2, and that's going to be C prime. All right. So now here are my 3 new points. There's my reflected triangle. Okay, A prime, B prime, C prime. And then it says I'm going to rotate 90 degrees about the origin. Okay, so now that I have done the reflection, guys, I'm only looking at these numbers in green. I don't care about these other numbers anymore. I've already done my reflection. Okay, so if you guys remember the way I taught you, how do you do a rotation? What do you do with the x and y first? You switch them. Okay, so my A, and this is going to be double prime because I'm doing two transformations. So my A double prime, I'm going to switch these guys. I don't care about the signs right now, guys. I don't care. Just switch them. Just switch the x and the y. That's going to be 4 and 3. Don't care about the signs. B double prime, I'm going to switch those guys. That's going to be 2, 6. And then C double prime, that's going to be 2, 1. And now the way I taught you was do your rotation, figure out which quadrant you're in, and that will tell you what the signs need to be. Okay, so what are we doing here? We're rotating 90 degrees. Now, if they don't tell us, guys, which way are we going? We are going counterclockwise. I'm pretty sure on the EOC they'll tell you whether it's counter or clockwise, but if they don't, we got to assume we're going counterclockwise because that's the way the quadrants are numbered. 1, 2, 3, 4. They're numbered in counterclockwise fashion. Okay. All right, so let's take each of these one at a time. A. And draw yourself, I told you this in class, draw yourself a picture, guys. Draw yourself a picture. We're going 90 degrees counterclockwise. Every time I'm turning the doorknob 1 quadrant to the left, okay? So let's start with A. If I go counterclockwise, this guy, I'm going to do that, I guess I'll do this in red. This guy, where are we throwing him? Counterclockwise, we're going to throw him into the 4th quadrant. What are all the signs in the 4th quadrant? They are positive, negative. Okay, so that tells me that A double prime's got to be positive, negative. Okay, 4, negative 3. All right, for B prime, where are we sending him? Counterclockwise, counterclockwise. We're sending B into the 1st quadrant. Everything in the 1st quadrant is positive, positive. So B, just leave alone, 2, 6. C is in the 1st quadrant. Counterclockwise, we're going to throw him into the 2nd quadrant. Everything in the 2nd quadrant is negative, positive. So C double prime is going to be negative, positive. All right, so there are my final 3 coordinates. So which one is the correct answer? The correct answer is B. 4, negative 3, 2, 6, and negative... Oh, sorry. I'm tired, guys. I apologize. I know you guys are tired, burned out. I am too. Everything, I just said this. Everything in the 2nd quadrant is negative, positive. Negative, positive. Okay. So the correct answer should be B. Negative 2, 1. Okay. Okay. We can do it. We can push. We can do it. Oh my goodness. OMG. One more page. Okay, let's do it. 57. What would be the final coordinates of a rectangle located at those 4 points after the following two transformations? T sub 8, -7, and then a D sub 2. This T, they're probably not going to give you this notation. They probably will tell you translate right 8 down 4 or something like that. But just in case, the capital T means translation. So the 8, -7 means I'm going 8 to the right, and the -7 means I'm going down 7. Okay, so basically what I have to do is I have to add 8 to all of my x coordinates, and I'm going to subtract 7 from all of my y coordinates. I'll do this in green. So I'm going to add 8, add 8, add 8, add 8 to all of my x coordinates. In orange, I'm going to subtract 7, subtract 7, subtract 7, subtract 7. Okay, so my first batch, A prime, I'm going to add 8. 8 plus 2 is 10. 3 minus 7 is -4. For B prime, 8 minus 6 is 2. 1 minus 7 is -6. For my C prime, 8 minus 2 is 6. -5 minus 7 is -12. For my D prime, 8 plus 4 is 12. 0 minus 7 is -7. Okay, so that's after the translation of right 8 down 7. Now this, what does this D sub 2 mean? D means dilation. I'm dilating by a scale factor of 2. If it says D 1/2, that means you're dividing by 2. If it says D3, that means you're multiplying by 3. So D2 means I'm going to take all these coordinates and I'm simply going to multiply by 2. So if I multiply 10 times 2, that gives me 20. Look at your answer choices. The only answer choice that has a 20 is this one. So I already know that the answer choice is the correct answer is A. But let's just check. 20, -4 times 2, yep, -8. 2 times 2, 4. -6 times 2, -12. 12, -24, 24, -14. There we go. That checks out. Correct answer is A. 50A, solve the following system of equations. Mr. Manice, what you doing? Yeah, solving these systems are tough. Okay, this one is actually a line and a circle. Okay, so if this is the case, you can't graph this because you can't graph circles on a TI-84 calculator. So you will have to do this manually if you see this. Solving a system, you got elimination, substitution, graphical method. I don't want to be graphing a circle and a line. Okay, so I'm going to use substitution. The reason why that is because I already have one of my variables isolated. I already have y by itself. Okay, so what I'm going to do is everywhere I see a y, I'm going to replace it with that expression. So in the second equation, this y squared here, I'm going to stick in right there for y. I'm going to replace it, substitute a 3x minus 5. So the bottom equation is going to be x squared plus y squared. So that's going to be 3x minus 5, but I got to square that. And then that's going to equal 25. So guess what I got to do, boys and girls? I got to FOIL that out. FOIL. All right, I still got my x squared. FOIL, I need to expand this out. So I've got a 3x minus 5 times another 3x minus 5 equals 25. All right, FOIL. First, we also got this x squared. First, 3x times 3x is 9x squared. Don't forget to add your exponents. Outside, 3x times -5 is -15x. Inside, -5 times 3x is another -15x. Last, -5 times -5 is plus 25. That equals 25. And I can combine my like terms there. I can combine 1 apple plus 9 apples is 10 apples. -15 oranges minus 15 oranges is -30 oranges. And then 25, if I move this to the other side and subtract 25, guess what? Bye-bye, bye-bye. They cancel. So this is just going to be equal to 0. All right, now, how am I going to solve this quadratic equation? If you want to use quadratic formula, boys and girls, knock yourself out. I can do this in about 15 seconds if you correctly learn all the 7 methods for solving quadratics. Go ahead and look on over there to the wall. I don't care if you're in your bedroom. Look over there at the wall. I want you to imagine that chart that I've had up all year long. What's the first thing on the chart? GCF. Can I pull out a greatest common factor? Yes, I can. They both are divisible by 10, and they both have an x. This guy's got 2 x's, this guy's got 1 x. So I can factor out a 10x. Divide by 10x. That's going to leave me with x. negative 30x over 10 is minus 3 equals 0. Okay, when you do the GCF, guys, one of your factors is always going to be 0. I've got to set both of these equal to 0. So if I literally set 10x equal to 0 and divide by 10, guess what? One of my factors is 0. What do I do with this guy? If I set x minus 3 equals 0, add 3 to the other side, my other x is going to be 3, right? Flippy flip, flip the signs. So I just found the two root solutions. I just found the x's to this quadratic, okay? But the solution to this system of equations are two coordinate points, 4, 1 and 5, 2. Because what's happening here is I've got a circle on the coordinate grid. I've got a circle, and I have some line, okay? That's going to intersect the circle at two spots. Those are two coordinate points, 4, 1, 5, 2, whatever. So I just found the two x values. So what I'm going to have to do is I got to find the two matching y values that are associated with these two x's. So what I'm going to have to do is I'm going to have to take this guy, I'm going to have to plug this in for x and figure out what the matching y is. Okay. So if I plug in a 0, I'm going to have y equals 3 times 0 minus 5. 3 times 0 is just 0. So y equals negative 5. So one of my points is going to be this 0, comma, the associated y, negative 5. And then I got to do the same thing all the way over here. Plug in a 3 here. So my other y is going to be 3 times this 3 minus 5. That's 9 minus 5. That's 4. So my other matching coordinate is this other x, and then the 4, 3, 4. Alright, so what's the correct answer? Correct answer is 0, 5, and 3, 4. So correct answer is A. Okay, now if your brain drops out on Tuesday and you don't remember how to do any of this, what can you do? A lot of guys are probably looking at the video saying, Mr. Bernice, I can just plug in the answers immediately. Yeah. Yes, you can do that. However, I want you to be able to do it mathematically. I want you to be able to do it the way you've learned how to do it. All these tricks that I've shown you, plugging in answers until it's right, guys, those are just contingent backup plans, okay? You're not going to be able to get through high school math and college math, always trying to do guess and check. Guys, there is no guess and check in the real world. All those pumps and heat exchangers and pieces of equipment that I sized as an engineer, there's no guess and check. There's no, hey, I think I need a 145 horsepower pump. Let's see if that works. There's none of that. You really need to learn how to do these the right way, with the caveat that if you forget, if you can't remember, yes, you can go back and use the calculator trick. Yes, I can go back and plug in a 0 for x and a negative 5 for y and see if they match. Okay, yes, you can do that. Okay, sorry, I just had to get off my little soapbox there. 59. What is the measure of the sum of the interior angles of a 14-gon and the sum of the exterior angles? Now, guys, you're going to have to memorize these formulas. That little Chapter 5 graphic organizer under Student Guided Notes, not Student Guided Notes, under graphic organizers on my website under Resources, that has all these formulas, okay? So if you remember, our formula for the sum of the interior angles is n minus 2 times 180. Oh my gosh, Mr. Bernice, I don't remember that. Well, we did our little opening activator on that day, and I had you guys draw a pentagon or a hexagon. I said, how many triangles can you form in a pentagon? A pentagon has 5 sides, right? How many triangles can I form? 1, 2, 3 triangles. Well, guess what? N minus 2, 5 minus 2 is 3, right? I can form 1, 2, 3 triangles. So this n minus 2 business is just the number of triangles that you can form in any polygon. Well, what's this 180? Well, those are the 3 angles of a triangle. So that's why it's the number of triangles times 180 degrees. That's how we get this formula. Okay, so, but if you don't remember that, we can just plug in the number here. We got a 14-gon, so we got 14 minus 2, n is 14, times 180, that comes out to be 2160 degrees for the sum of the interior angles. So it's either A or B. Then it says what is the sum of the exterior angles. Guys, it doesn't matter whether I have 5 sides or a million sides. The sum of the exterior angles is always going to be 360, okay, every single time. So go back and look at that graphic organizer if that stuff is not fresh in your memory. Number 60, using the diagram to the right, what would be the angle of elevation to make sure that this plane doesn't run into the building? Okay, so this is trigonometry. What did I teach you to do? Step 1, I want you to circle the angle. Number 2, I want you to label everything. The 200 is your adjacent. This length is my hypotenuse, but there's nothing there. Guys, don't label it if there's nothing there. This guy is going to be my opposite. That's the one that's farthest away. And I'm going to get out my Bible and I'm going to pray that they don't do this to you guys on the EOC, because this is just downright mean. This is disgusting. You cannot use 60 and 200. Look at the units. 60 feet and 200 yards. Oh my gosh, Mr. Moniz. I know, I'm sorry. 60 feet times 3 feet and 1 yard. Make sure your units cancel, so 3 goes in the bottom. Sorry. 60 divided by 3, that's going to be 20 yards. That's dimensional analysis that we learned. So this is going to be 20 yards. I'm hoping they don't do that to you guys, but if they do, we have reviewed it. So watch those units. Alright, so I'm going to use opposite and adjacent. Here's where you're going to pull up your formula sheet. Which of our trig functions has opposite and adjacent? That's this guy, tangent. But remember, guys, I'm trying to find an angle. We only use tangent when they give us the angle. When I'm trying to back calculate the angle, I am going to use the inverse tangent of opposite, 20, over adjacent, 200. Okay, so how do I do inverse tangent, Ms. Bernice? Those are the guys in blue right here. Okay, inverse sine, inverse cosine, inverse tangent. Guys, I've taught all my students, but if I don't teach you, I'm not sure if your teachers warned you about this or not, but they are going to clear your calculators at the start of the EOC, right? When they clear your calculators, it is going to default back to radian mode. Okay? So when they put that calculator back in your hand, it's going to look like this. So please make sure when they put the calculator back in your hand after it's reset, go ahead and do the little storing thing. 3 store alpha A enter, 4 store alpha B enter. Go ahead and assign numbers to all the letters real quick, but make dang sure, please, that you are in degree mode, or none of this stuff on trigonometry is going to work. Okay, so I'm in degree mode. So now I'm going to press second. I want inverse tangent, that's in blue. So second inverse tangent of 20 divided by 200. Take 2. 20 divided by 200, and that gives me an angle. Take 3. That gives me an angle of 5.7. Inverse tangent of 20 divided by 200. Okay, does that make sense? Let's use common sense, guys. This plane is 200 yards away. It's really, really far away, and the building is only 20 yards tall. So would you expect this angle to be really small or really steep? It's going to be really small because this length is a lot longer than that length. So yeah, I buy 5.7 degrees. That makes sense to me. I wouldn't buy an angle that's 70 degrees. No way. Okay, it doesn't make any sense. Okay, I'm about worn out, guys. Y'all should be paying me for this. I'm going to charge like $100. I'm going to charge every student like $100. What do you think about that? All right, 61. Are the two triangles at the right similar? How do you know? Okay, well, guys, all these triangles, all these proofs, SSS, all that stuff, remember, you're asking yourself, where can I add arcs and ticks to my diagram? They have already given us boxes here and here. Where else can I add stuff? Arcs in the middle, right? Always arcs at vertical angles. Is that enough for me to say that the two triangles are similar? Not congruent. Not congruent, similar. And if you remember, I think we had a problem like this earlier. Our similarity statements were SSS, our similarity postulates were SSS similarity, SAS similarity, and AA similarity. Y'all remember that? AA squiggly? I think we had that earlier in the packet. So yes, I have angle, angle, squiggly. Angle, 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 angle. Because our third angles theorem says if two angles match, then the third angles have to match. Okay? So yes, that's enough. These two triangles are similar by AA squiggly. Okay, come on. There you go. Camera. 62. We're close. Which of the following would allow you to prove the two triangles congruent by the HL theorem? That is hypotenuse leg. Hypotenuse leg theorem. Technically, this is the fifth one of our congruence theorems. SSS, SAS, ASA, and AAS. Hypotenuse leg was the fifth one, but this only works when you have a what? A right triangle. Hypotenuse. You don't have a hypotenuse unless you have a right triangle. So which of these allows me to use HL? Okay, so HL says that I have to have two triangles that are both right triangles. The hypotenuses have to be the same. There's your H. I have to have ticks on the hypotenuses, and I just need a pair of ticks on one of the legs. Okay, that's enough. Okay, Technically, this would be what? ASS. That's a bad word, right? We said ASS doesn't work. It does work with a right triangle, hypotenuse leg. That's why we call it that. All right, so let's look here. AB is parallel to CD. I need another set of ticks, guys. I need another set of ticks here and another set of ticks here. Do these lines being parallel, does that help me with lengths? It doesn't help me. It helps me with the Z. I can put little arcs here in the crevice of the Z, but I don't need any more angles. I need ticks on the legs. Okay, hypotenuse leg. That didn't help me. Let's look at this one. Angle A, if you tell me angle A is congruent to angle C, well, that's the same thing. That's what the lines being parallel tells me. That doesn't help me. Okay. If you tell me that OC, this length, is the same as OD, that just lets me put double ticks on this same triangle. That doesn't tell me anything about this triangle. So by default, this one has to be correct. But let's check it out. O is the midpoint of AC. So that means we're cutting AC in half. So I got double ticks on AO and double ticks on OC, and there you go. Okay, that's enough. Now I've got a leg and a leg, hypotenuse, hypotenuse, and two right angles. All right, so the answer is B. Okay, 53. If CD is the perpendicular bisector of AB, which of the following must be true? Okay. CD is a perpendicular bisector of AB. If you see that, guys, whatever comes after the word of, okay, of, same thing right here, whatever comes after of, that's the one that you're bisecting. We are bisecting AC. We are bisecting AB. So that means that AM and MB are the same length. Which of the following must be true? AC is that distance the same as BC. If we're on the perpendicular bisector, guys, does that mean that we create an isosceles triangle? You betcha. Okay. Anywhere on this perpendicular bisector, anywhere is going to be equidistant from these endpoints. It doesn't matter where I am. Always equidistant. So that's true. Angle M is 90 degrees. Is that a box? You betcha. Perpendicular. Okay, perpendicular bisector, 90 degrees. AD is AD the same as BD? Is that length the same as that length? You betcha. So the correct answer is all of those. I need some confetti or something. I need something to celebrate. The area of a circle is given as 217 millimeters squared. Which of the following would be the correct formula for solving for the radius? Okay, you will have this on your formula sheet. The area of a circle is pi r squared. Okay, but now they tell me that the area is 217. So I just plug this in right here. So 217 equals pi r squared. They want to know which one of these is correct for solving for the radius. How do I get r squared by itself? First thing I need to do is get rid of this pi. That's being multiplied, so I've got to do the opposite. So I'm going to divide both sides by pi. So I have r squared equals 217 divided by pi. Nobody cares about r squared. They're asking me about r, the radius. So I'm going to have to take the square root of both sides. So r is the square root of 217 over pi. No, sorry, 217, square root of 217 over pi. Guys, I'm tired. I love you guys to death. It's the reason I do all this for you. It's the reason I put all this work into what I do. All these posted solutions, games, videos, all this kind of stuff is because I care about you. And I want you to do well. Some of you guys are on the verge of passing and failing. And this EOC is going to make you or break you. This is 3 hours worth of information. If you're on the verge of passing or failing, watch it twice. Mr. Manise, that's 6 hours this weekend. Yeah, 6 hours. Life is hard. Geometry is hard. It's the hardest thing you'll probably ever do in high school math for a lot of you. You got to put in the work. You got to put in the effort. Go back and rework these problems. Go to my website and click on that 182-page document from the Georgia State website. Skim through. Go to the table of contents. If you're weak on quadratics, go to the quadratics unit. Go to the table of contents, boom, there's the quadratics unit. If you're weak on circles, go to the circles unit, refresh your memory in the packet, work through some of those example problems. The answers are in the back of that packet. In fact, I believe the answers start, I think, on page like 167 of that document. So work some of those sample problems, go to the back and check your answers. Go through and look at these posted solutions, whatever you got to do, okay? Come to the review session that I'm going to do. and I'll stay as long as it needs. I'll stay till dark. Okay. Hope you guys enjoy these videos. I wish you the best of luck on the EOC. I'm crossing my fingers that you guys can pass. I'm crossing my fingers that you can make that A, you can make that B, whatever grade you want. And this is going to be the last geometry video of the year. This is Mr. Renee signing off. Good luck on the EOC, and we will see you later.